Hi guys, today we're going to conduct an experiment involving light and lenses. In this experiment, we're going to investigate the relationship between object distance u and image distance v. Then we're going to investigate the relationship between the object distance u, image distance v, and the focal length f of a lens. Lastly, we're going to determine the focal length of the lens that we use in this experiment using the formula 1 over f equals to 1 over u plus 1 over v. Okay, in this experiment, we need a power supply, a light bulb holder, a light bulb, a lens holder, a thin convex lens, a screen. You can make one out of cardboard and stand just like I did here. Just make sure you can read the scale of the ruler before taking measurements during the experiment. Connecting wires, a ray box crosswire patcher. Again, you can make one out of a box like I did here. For the crosswire patcher, cut out a triangle shape and tape wires in a cross position like I did here. Then place it at the opening of the box to complete your ray box. Lastly, a meter ruler. So, for the apparatus, connect the power supply to the power outlet. As a safety measure, make sure it is not switched on while connecting the rest of the setup. Take your light bulb holder and screw in the light bulb. Then connect the light bulb holder circuit to the power supply. Place the ray box over the light bulb. Place a meter ruler at the start of the aperture screen. This is so you can measure the distance between the object, or in our case the crosswire aperture, and the lens. Place the lens holder with lens 15 cm from the aperture. Place the screen around 15 to 20 cm behind the lens. You may have some problems aligning the light bulb, aperture, lens, and the screen. So feel free to adjust the height and positions of the lens and the bulb in the ray box. Just make sure the distance of the lens is exactly 15 cm from the aperture, and the ruler it forms a straight line between the aperture, lens, and screen. Now to conduct the experiment. With the lens set at 15 cm from the aperture, turn on the power supply and then adjust the screen until the image of the triangle crosswire is formed. Do note that the triangle should be upside down or inverted vertically as it passes through a convex lens. Finally, adjust the distance of the screen back and forth so that the image is as sharp as possible. Measure and record the distance between the lens and the screen. Reset the apparatus by placing the lens 20, 25, 30, 35, and 40 cm away from the ray box, and then adjusting the screen accordingly till a sharp image of the aperture is formed. At each step, record the distance between the lens and the screen. Tabulate your data. And now for the results. So the image distance that I got for each reading is 35.3 cm, 22.3 cm, 18.2 cm, 16.2 cm, 15.1 centimeters, and 14.3 centimeters. Calculating the respective 1 over u and 1 over v will give us these values. Now here's where it gets interesting. When we add up the two together, we will get a value of 0.095 for all values of u. Hence, we can establish that relationship between the object distance and image distance to be 0.095 equals to 1 over u plus 1 over v. Now let's look at 1 over u plus 1 over v. From the thin lens equation, 1 over f equals to 1 over u plus 1 over v. Hence, we can calculate the focal length of the lens used in this experiment. Since 1 over f equals to 0.095, solving for x, we would get a focal length of 10.5 centimeters. Well, that's all for today. Not bad for a quick experiment, I must say. Now you guys know how to determine the focal length of a convex lens. Go give it a try when you have a chance. I hope you learned something today, and as always, Thank you for watching.